On this video, we will be talking about the difference between an empirical formula and a molecular formula, and of course how to find each of them in a given problem. So first let's define each of them. For molecular formulas first. Formulas. Right. The molecular formula of a compound will show its actual elemental ratio. So its actual elemental ratio. That is for a molecular formula. However, an empirical formula is somehow different. Okay, the empirical formula will show the simplest numerical ratio of that compound. So simplest numerical ratio. Numerical ratio. So in other words, it will be this. It will be actual versus simplest. This would be molecular and this would be empirical. And to reference it better, I'm going to show you an example of a molecular formula and an empirical formula. So let's say you have a compound like this, C4H8O6. Now this would be its molecular formula, because that is its actual ratio. That is how the compound is. Now if you want its empirical formula, it'll be the simplest. So by simplification you can get it by some C2H4O3. You can't simplify this anymore because of this 3. So this would be its simplest form. So this would be its empirical formula. And if you think about it, these are not the same. This is just a simplest way, a very simple way of representing this, of representing the actual formula. So keep in mind that these are not the same. When they ask you for the empirical formula, that is just the simplest way of representing its molecular ratio, its actual ratio. So let's solve an actual problem. Now I'm going to give you a method to find the empirical formula and later the molecular formula in a given problem. So let's do this by steps. First, you will want to find the moles of each element. And you will be doing that by molar conversion. So if you don't know how to do how to compare using the mole, I would recommend going back to one of the previous videos I made on molar conversions. After you found the moles of each of the elements, you will want to divide each of them. Divide each by the lowest one. By the lowest. By the lowest, I mean the moles. If you got for an element 2 moles, if you got for another one 0.5, and for another one 5, you will divide this by 0.5, this by 0.5, and this by 0.5. So you will use the lowest. Now this will give you a number, and that number will be the ratio of each element in the formula. So let's say this was carbon, this was hydrogen, and this was oxygen. So you would get, for carbon, you would get 2 over 0.5, which is 4. For hydrogen, you would simply get 1, and for oxygen, you would get 10. And you don't represent the 1, so I was just showing you how it would look, but you write it like that. This will be your empirical formula. Empirical formula. Now, the next step, in that problem you will usually be given a molar mass. So you'll have the molar mass of the whole compound. You'll have the molar mass in this case of this whole thing. But you want to find the empirical mass to know if this is if the empirical formula is equal to the molecular formula, or if there is a separate molecular formula. So to find the empirical mass of something, you will just simply get its normal molar mass, like you did before. So for this one, if I'm not mistaken, the empirical mass or molar mass is about empirical mass 209 grams per mole. And let's say, for the sake of the problem, that the given molar mass at the beginning of the problem was 418. So the given mass, you can call it was 418. So you will divide. Let me erase this part. So the third step would be to divide the given mass over the empirical mass. So it will be like this. It will be like this. Given mass over empirical mass. So for this case, it would be the given mass is 419. The empirical mass is 209. So it would simply be 2. And what you will do with that 2 is that you will multiply it by the empirical formula you have. So it would be C4H010. You will multiply this by 2. So it would be C8H2O20. And that would be your molecular formula. However, if the given mass was the same as the empirical mass, so it would have been 209, you would have gotten here, instead of 2, you would have gotten 1. So if you multiply this by 1, you will get that the molecular formula is the same as the empirical formula. So let me erase all this. So simply, you would say that, I think it was C4H010, the empirical formula is equal to molecular formula. So this is both your empirical and your molecular formula. Now let's do a real problem. I found this problem on the internet, so just let's solve it. You have 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. And they're asking you for the empirical formula and the molecular formula. So those are your two questions. Well, now the first step, as I told you, was to get the moles of each element. So actually, they didn't ask for the molecular formula, but I will just let it be. And yeah, let's just find the empirical formula first. So the first step, as I was saying, is to convert each of the elements into moles. So as I explained before, you simply use the molar mass for each element. So 1 mole, and you will write down the molar mass of each. As you can, it will actually be the atomic mass of the element, because it's simply an element. So I think calcium is about 40 grams, oxygen, let's say 16, and hydrogen 1. These are not the exact numbers, but just to make it a little easier. But you have to use 15.9 for oxygen or something to get it a more exact number. Now this would give us, let's see, this would give us 0.33 moles, because the grams will cancel out. This 0.675 moles, and finally 0.675, the same. It's actually a little bit more, because actually a little bit less, sorry, because this is 1.008, I think it was, but it doesn't matter for now. It'll give us the same. So the second step was finding the smallest one, and because we have two as the same, it doesn't matter. We'll just use one of them, let's say this, and divide it. So for the case of calcium, you can write it here. It'll be 0.33. Actually, no. I don't know what was I thinking. This is the smallest. Sorry. So it would be not this. It would be 0.33 over 0.33. The oxygen would be 0.675, 0.33, and the hydrogen would be 0.675, again 0.33. So for this we'll get 1, so you don't write it. For oxygen we'll get about 2, and for hydrogen we will get about 2. And that would be the empirical formula, right? One more thing, if you get, if right here you get, let's say 1.9, that is, you can say that is 2. It's different if it's 1.5, something like that. So I'll explain it later. I will actually do another video just to show how the 1.5 one works. And now, it didn't say what its molar mass was, so that would be it for an empirical formula one. And just to get the more accurate formula of it, then ask for it, you just, as I said before, divide the given mass over the empirical mass, and if you get 1, it is the same. If you get 2, you multiply this by 2 or 3 or 4. Well, that's it for empirical formulas and molecular formulas. As I said before, I'll be given, I'll make another video just to show you what happens if it is 2.5 or 2.25.